We have the definite integral from negative pi to pi of the cosine of z over the square root of 4 plus 3 sine of z dz. And we want to take, when we're doing these, we're practiced at this point. We've already covered indefinite integrals, definite integrals, integration by substitution, and now we're doing using integration with substitution and definite integrals. So we should be pretty well practiced at this point and able to take some little bit of leaps and hopefully cut down our work. So what I'm going to do, since this is trig and it's a radical and it's in the denominator, I kind of know something's going to happen here. So I'm just going to take a chance, and I'm going to say let u, usually I would just say let u equal 4 plus 3 sine of z, and then of course the derivative of that is 3 cosine of z, and I would have part of that in the numerator, so that would help me out. But I'm going to go ahead and take a chance here, and I'm just going to say, because I've worked enough of these, and at this point, and I kind of have an intuition about this, that if I go ahead and let u equal 4 plus 3 sine of z, and then take the derivative, or take differentiate both sides anyway, take the differential, so I'll have du equals, I'll just go ahead and do that. This will be, because this is 4 plus 3 sine z to the 1/2, so this will be 1/2 times 4 plus 3 sine of z to the negative 1/2 times the derivative, remember this chain rule, times the derivative of the inside is 3 cosine of z, and then of course dz, and then we'll just rewrite this a little bit to make it easier to see that we actually have almost exactly this, our integrand. So we're going to have 3 over 2 times the cosine of z over, because this is a power of negative 1/2, the square root of 4 plus 3 sine of z dz. Well, look at that. I mean, the cosine of z over the square root of 4 plus 3 sine of z, I have that exactly in my integrand here. So all I need to do is multiply both sides by 2/3 to get 2/3 du equals the cosine of z over the square root of 4 plus 3 z dz. And I'll make that substitution. And I'm also going to change my limits of integration too, because I don't want to go and do an indefinite integral and then come back, and that's just too much work. I think it's better to do, you may not think so, but I like it. And students resist doing this, changing the limits of integration when they make a substitution, but I see a lot of mistakes made when they don't, and they forget to go back. And anyway, so I'm going to do that, and I just wrote that these are my limits of integration of u equals to remind myself that this is what u equals. So now I just have the cosine of z over the square root of 4 plus 3z dz is equal to 2/3 u. 2/3 du, which will be very easy to integrate. In fact, if you notice, what I just did there is I integrated before even doing it. So now I'm going to change my u limits of integration, and the way you do that is you say, well, x equals, you take your lower limit of integration in your original and definite integral, and x equaled negative pi, which implies that I'm sorry, it's not x, it's z in this case. I'm all for like changing, using different variables, but I don't know, sometimes it's a little ridiculous. So, man, I'm a little ridiculous. I wrote an x again. It needs to be a z. So if z originally equaled negative pi in our original definite integral, then that implies that u equals the square root of 4 plus 3 times the sine of negative pi. Well, the sine of negative pi is the negative sine of pi, and the sine of pi is 0. So we have 4 plus 0 is 4, and the square root of 4 is 2. So we can actually say that that's 2, and then we can change our upper limit if z equals pi. This is kind of interesting what happens here. I was just thinking I made a mistake, but no, this doesn't make a mistake. The net area under this curve is going to be this. So this implies that u, same thing is going to happen here, equals 2. And so 2, I mean, we could integrate here, but honestly, you're given a property that tells you when you integrate from of that line, well, the area under that curve is just 0. But if you wanted to integrate, you would get 2/3 u, and then you would evaluate it from 2 to 2.